Welcome back, everybody, for another deep dive. This time, we're going to take a closer look at helium.
Yeah.
The thing that makes balloons float, makes your voice sound kind of funny.
Right.
But helium is so much more than just party tricks
Oh, yeah.
and silly voices.
It's fascinating.
This stuff is really fascinating and has this incredible story that goes way beyond Earth, all the way to the sun.
To the sun, exactly.
Yeah.
Yeah. Helium's discovery actually started with astronomers
Oh, wow.
of observing a solar eclipse way back in 1868.
Wow.
And they saw this strange yellow line
Okay.
in the sun's spectrum that didn't match any known element here on Earth.
Huh.
And they figured, hey, this must be something new,
Okay.
and named it helium after the Greek word for the sun, helios.
So, wait, they found helium on the sun before they found it on Earth?
Yep.
That's crazy.
Pretty wild.
How did we finally catch up and find it down here?
It took a few decades.
Oh, wow.
It wasn't until 1895 that scientists were working with this mineral called clavate
Okay.
and noticed that it released a gas when they treated it with certain acids.
Okay.
And when they analyzed the gas's spectrum, boom, that same yellow line.
Wow.
Helium officially on Earth.
That's a pretty cool origin story.
Mm-hmm.
But if it comes from the sun, how much is actually here on Earth? It's super rare.
This is where it gets really interesting. So helium's actually the second most abundant element in the universe, right after hydrogen.
Oh, wow.
We're talking a whopping 23% of all the mass out there,
Okay.
but on Earth, yeah, it's pretty scarce.
Wait. How can it be so common in the universe but rare here?
Yeah.
That doesn't make sense.
Well, that's because most of the helium on Earth wasn't here from the beginning.
Okay.
It's actually being created all the time
Oh, it's
through the radioactive decay of
Oh.
elements like uranium and thorium.
so it's like constantly being generated.
You got it. So these heavier elements emit alpha particles,
Okay.
which are basically helium nuclei. And over millions of years, that decay produces the helium we find trapped in natural gas deposits.
Oh, wow.
But get this. Once that helium is released into the atmosphere,
Uh-oh.
it's so light that it escapes into space.
Seriously. So we've got this precious element being born and then floating off into the cosmos.
Yeah.
That kind of makes you think about how we use it, right?
It definitely raises some questions about conservation, finding sustainable ways to manage this finite resource.
Yeah.
But before we get into that, let's talk about something pretty wild. Have you heard about liquid helium?
Liquid helium. Okay, I think this is where things are about to get really weird.
Oh, you have no idea.
Yeah.
Liquid helium basically throws our everyday understanding of physics right out the window. It becomes what we call a superfluid.
A superfluid.
Yeah.
What does that mean?
Well, imagine a liquid that flows without any resistance.
Okay.
Like, it's completely frictionless. It can even defy gravity.
Wait, is he going to start climbing walls or something?
Well, there's this phenomenon called the creeping effect. Okay.
Where liquid helium can literally crawl up and over the sides of a container.
What?
Yeah, it can even squeeze through these incredible tiny cracks
Wow.
that no other liquid could get through. And then there's the fountain effect, where it seems to defy gravity and shoot upward like a fountain.
Okay, that's officially blowing my mind.
Yeah, it's wild.
This is like straight out of a science fiction movie.
It's actually straight out of quantum mechanics.
Oh, wow.
These bizarre behaviors are quantum effects happening on a scale we can actually see, which is really rare.
So we've got this element born from the sun. It's both abundant and rare. And then it goes and breaks the laws of physics when it gets cold enough. Helium is starting to sound like the most interesting element on the periodic table.
It's definitely up there. And we haven't even gotten to the part about all the amazing things we can do with it. It's not just about balloons and funny voices.
All right, you've got me hooked. Let's talk about those applications next time. So, when most people think about helium, they think about balloons at a birthday party or something.
Right.
But that's really just scratching the surface.
Okay.
Helium's unique properties make it absolutely essential for some really incredible applications.
All right, so spill the beans. What are these amazing things we can do with helium besides, making things float?
Well, one of the most significant applications is in cryogenics.
Okay.
Specifically for cooling superconducting magnets.
Cryogenics. That sounds pretty intense. What does that even involve?
Well, it basically means working with extremely low temperatures.
Okay.
And when it comes to getting things cold, helium is the champion.
Oh, wow.
It can cool things down to temperatures just a hair above absolute zero.
Wow.
Which is crucial for certain technologies to function.
So what kind of technologies? Give me some examples.
Well, think about MRI scanners.
Okay.
those giant machines that let doctors see inside the human body without surgery, they rely on superconducting magnets to create those incredibly detailed images.
I see.
Yeah.
Okay, I'm following you so far. But how does helium fit into all of this?
Those superconducting magnets need to be kept ridiculously cold
Oh, okay.
to work their magic.
Okay.
And that's where liquid helium comes in.
Okay.
It's the key to achieving those super low temperatures and keeping those magnets functioning properly.
Wow, so helium isn't just about fun and games then. It's literally helping to save lives. I never would have guessed that.
It's pretty remarkable, right? And that's just one example. Helium is also a really vital component in certain types of welding.
Welding.
Yeah.
How does helium come into play there? It seems like kind of a jump from MRI machines.
It acts as a shielding gas,
Okay.
protecting the weld from contamination by the surrounding air.
Okay.
This is especially important when you're welding metals that are really easily oxidized or react with nitrogen at high temperatures.
It's like a protective bubble around the weld, making sure it's strong and pure. Oh. That's pretty ingenious.
And then there's leak detection.
Leaks detection. Are we talking about like leaky faucets and stuff?
Well, not quite. We're talking about leaks in all sorts of systems, from like high vacuum equipment to really complex pipelines.
Why?
Helium's ability to diffuse through solids much faster than air makes it the perfect tracer gas for finding even the tiniest leaks.
So you basically introduce helium into a system and then look for where it escapes to pinpoint the leaks.
Precisely.
I could see how that would be super useful in a lot of different industries.
Oh, absolutely. It's used in everything from manufacturing to aerospace to ensure the integrity of these really critical systems.
So we've covered cryogenics, we've talked about welding and leak detection. Are there any other areas where helium is making a big impact?
Well, there are plenty. Helium is also a critical component in scientific research,
Okay.
particularly in fields like low-temperature physics and quantum mechanics. Remember those bizarre properties of liquid helium we were talking about earlier?
Yeah. The creeping, the fountain effects, how could I forget?
Well, those properties make liquid helium an incredibly valuable tool for scientists who are studying the fundamental laws of the universe at extremely low temperatures.
It's like the weirder helium gets, the more useful it is for science.
That's a great way to put it. And of course, we can't forget about helium's use in airships and blimps.
Ah, yes, the classic image of a giant helium-filled airship floating across the sky.
Exactly.
But honestly, compared to these other applications, the amount of helium used for that seems pretty small, right?
You're absolutely right. It might be the most visually striking use of helium.
Yeah.
But in terms of volume, it's actually a very minor fraction of the total global consumption.
So what does this all mean? We've got an element with this incredible origin story, a whole bunch of really unique properties and applications that span from like medicine to space exploration. Helium's kind of a big deal, isn't it?
It's absolutely crucial to many aspects of our modern world. But as we touched on earlier, it's also a finite resource. Right.
And that brings us to a critical question.
Yeah.
How do we ensure a sustainable future for this remarkable element?
That's a really great question. I'm definitely curious to hear your thoughts on that.
Yeah.
Let's explore those challenges and potential solutions next time. Okay, so we've talked about how amazing and versatile helium is, but it's a finite resource.
Yeah.
What are we doing to make sure we don't just run out? Like, should we all be ditching balloons for birthday parties?
Well, giving up party balloons might be a nice symbolic gesture.
Yeah.
But I think the real solutions are going to require some more serious innovation.
Okay.
And a shift in how we think about helium as a resource.
Okay, so what are some of the things we could be doing on a larger scale to kind of address this issue?
Well, I think one of the biggest areas of focus is improving our helium recycling efforts.
Okay.
You know, a lot of the industrial processes that use helium, they could capture and purify that gas for reuse instead of just letting it escape. Yeah, that makes a lot of sense. It's like closing the loop on the helium life cycle.
Exactly, yeah. And there's also a lot of research going on right now to find new sources of helium.
Oh, okay.
So some scientists believe there might be these untapped reserves deep within the Earth's crust, maybe even associated with volcanic activity.
Volcanic helium? That's a wild thought.
It's definitely an area of active research.
Okay.
And if it pans out, it could be huge.
Yeah.
But beyond finding new sources, we can also think about maybe exploring alternatives to helium in certain applications.
Okay.
So, for example, in some welding processes, argon can be used as a shielding gas instead of helium.
So it's all about finding creative solutions, whether that's conserving the helium we have or finding new sources or even coming up with alternatives where possible.
Absolutely, yeah. And this isn't just a scientific challenge, it's an economic one as well.
Right.
You know, the price of helium has been fluctuating a lot in recent years,
Yeah.
which highlights the need for maybe smarter policies and regulations to make sure we've got a stable supply
Right.
for all those industries that really depend on it.
Wow. This deep dive has really been eye-opening.
Yeah.
Helium is clearly an element that deserves our attention and respect, given how much it impacts our lives in so many ways.
I completely agree. And it makes you think, you know,
Yeah.
what other seemingly simple things in our world have these incredible hidden depths?
That's a really great point. It's a good reminder to never stop being curious.
Yeah.
And to always look deeper.
Absolutely. There's always more to learn, explore, and discover, even in the things we think we already know.
Well, that wraps up our deep dive into the world of helium. Thanks for joining us on this journey. We hope you learned something new and maybe even came away with a newfound appreciation for this really amazing element.
And remember, the journey of discovery never ends. Keep asking questions, keep exploring, and who knows what you might find.
Until next time, stay curious.